Welcome back to our study on statistical mechanics. We have been studying about quantum systems. We derived the condition for a system to be classical, and also from that condition we got what are the conditions for a system to be quantum. After that, what I had given you how we can change our classical statistical mechanics systems to quantum statistical mechanical systems. Therefore, now we are ready to study about, after these two things, we are now ready to study about quantum systems. The best example for a quantum system is black body radiations, that is the radiation emitted by a hot body. Therefore, in this section we will be studying about black body radiations, and it was Max Planck who obtained the expression for the energy density distribution of these black body radiations, which was given by U of nu d nu is equal to which 8 pi h nu cube by c cube 1 divided by e raised to h nu by k t minus 1 d nu, which we will be deriving later. And the frequency that was taken by Max Planck was E is equal to h nu, and one of the important point that we have to take into consideration is that actually the derivation, all these derivations that I am going to do now is not the way in which Max Planck derived the expression for black body radiations. This was derived as per the ideas of Satyendranath Bose, an Indian physicist. And we will be using our earlier equation for log set, which we developed from classical statistical mechanics incorporating the quantum properties. Therefore, the energy will be E is equal to h nu, and we will take that the particle, the basic particle that are responsible for the black body radiation is a photon, whose energy is E is equal to h nu, and the spin of the photon is 1, and the chemical potential, that is the work done to create a photon or destroy a photon, we will take that as the chemical potential will be is taken as 0. That is, no work is done to create or destroy a photon. They appear from vacuum and they disappear into vacuum. This is what Kersen-Huang says. Photons appear from vacuum and disappear into vacuum. There is no work that is known to us that has to be given for creating or destroying a photon. Using these ideas, we will be using this expression P v by k t. We are going to find out the thermodynamics of these photons. In the next section, I will be deriving the expression for the energy density or the Planck's distribution law. In the first section, what I am going to do is I am only deriving the thermodynamics exhibited by these black body radiations. Therefore, I will be deriving the pressure, I will be deriving the energy density, I will be deriving the Helmholtz free energy and also entropy. For the pressure is basically given by P v by k t is equal to log z, and log z we derived earlier that log z is equal to some over G I. G I is now a newly introduced factor, which is basically an intrinsic property, G I, degree of freedom. The photons will be there are two types of photons. There are two types of light radiations, that is longitudinal light radiations and transverse light radiations. Therefore, the photons can be in transverse form and longitudinal form. Therefore, every photon, when they are created, they can be in a longitudinal or transverse form. This will give rise to G I, which is equal to 2. Therefore, 2 and then logs 1 minus z e raised to minus beta e p, or E nu, we can say E nu, and then I can take that log 1 minus z, which can be taken as log 1 minus x as minus 1 x raised to L divided by L, and this log z can be converted in this format, and then that summation I can change to integration. And that summation, when I change to integration, then the number of states between p and p plus dp, or the number of states between nu and nu plus d nu will come, and the frequencies I told you, it is ranging from 0 to infinity, or the momentum is varying from 0 to infinity. That has to be taken into account. I am not going to the derivations just simply I show you all these things. Therefore, log z, when you substitute all these things, I will be getting this value of log z as that value 16 divided by 90, then all those terms will be there. You can see that this log z, which is equal to PV by KT, is proportional to T cube and also V. Or if you substitute your this sum over L equal to 1 to infinity as 1 by L raised to 4 as pi raised to 4 by 90, I will be getting P by KT as 8 pi raised to 5 K cube T cube divided by 45 H cube C cube. Or the pressure will be 8 by 45 pi raised to 5 K raised to 4 K raised to 4 T raised to 4 divided by H cube C cube. Or the pressure, the radiative pressure, the photons that are coming out of the sun or the photons that are coming out of any hot body, they will be showing a pressure which we can call it as the radiation pressure. The pressure will be given by 8 by 45 pi raised to 5 K raised to 4 T raised to 4 divided by H cube C cube. That pressure, or you can say that pressure, all the parameters except temperature, they are constants, or the pressure is proportional to 4th power of absolute temperature. Such a relationship for a pressure we have never derived. In earlier cases in our ideal gas, we have pressure is proportional to temperature. Now we had shown that pressure is proportional to 4th power of absolute temperature, which is basically a quantum property. And such relationship where any property proportional to T raised to 4, we call it as the Stephen-Boltzmann law. Therefore, any dependence of T raised to 4 dependence, we generally nowadays called as Stephen-Boltzmann law. There is a traditional Stephen-Boltzmann law which I will be giving you later, but nowadays any T raised to 4 dependence, we call it as Stephen-Boltzmann law. Therefore, we got the pressure that is exerted by the photons as proportional to, or it is 8 by 45 pi raised to 5 K raised to 4 T raised to 4 divided by H cube C cube. Now, next is how we can find the energy density. U is given by KT square dou by dou T of log z. Log z we got earlier. Substituting that value of log z, you will be able to get log U by V is equal to 3 times 8 by 45 pi raised to 5 K raised to 4 T raised to 4 divided by H cube C cube. Or 3 by 45 means it is 1 by 15. Or you can say that the pressure and energy density are related as pressure is equal to 1 by 3 U by V. The pressure and energy density are related as pressure is always 1 by 3 times the energy density of a photon. Photon is basically a relativistic massless particle. We can say a photon is relativistic massless particle. If the relativistic energy E is equal to root of P square C square plus m0 square C raised to 4, if you take m0 is equal to 0, it becomes root of P square C square. If you take the plus sign only, you take E is, you can get E is equal to Pc. And that is actually equal to h nu. Therefore, photon is basically a relativistic massless particle. For all relativistic massless particle, the pressure will be always equal to 1 by 3 times the energy density. This when you compare with the ordinary ideal gas, for an ordinary ideal gas, P is equal to nkt by V and E is equal to 3 by 2 nkt. Then if you take those relationship, you will be able to get the P and U, the relationship will be P will be equal to 2 by 3 times the energy density. Therefore, for a non-relativistic particle, the pressure and energy density are related by the formula P is equal to 2 by 3 times the energy density. For a relativistic massless particle like photons, the pressure and energy density are related by the formula P is equal to 1 by 3 times the energy density. Therefore, we had derived two formulas. One is the equation for pressure and the second one is the equation for energy density. Pressure was 8 by 45 pi raised to 5 K raised to 4 T raised to 4 divided by H cube C cube. Now, and U by V was 3 by 15 pi raised to 5 K raised to 4 T raised to 4 divided by H cube C cube. Now, we have to find other thermodynamic quantities. The next thermodynamic quantity I am going to derive is Helmholtz free energy. In grand canonical ensemble, Helmholtz free energy A is equal to minus kT log z nkt log small z, where small z is the fugacity. And fugacity we had, I already told you that z, small z is e raised to beta mu. But we had take with the chemical potential of a photon, mu is always 0. Therefore, e raised to 0 is 1. Therefore, z is 1. When z is 1, log z is 0. Log small z is 0. Therefore, A is only minus kT log z. And what is log z? PV by kT. Therefore, when you substitute, you will be able to get A is equal to minus PV. Very simple. But what is your P? P is equal to 1 by 3 times the energy density. Therefore, when I substitute that P is equal to minus 1 by 3 times the energy density, I will get A is equal to minus 1 by 3 times the energy only. Energy density was 3 by 15 into. Therefore, when I take energy, I have to multiply that with V. That is, you have 3 by 15 V into pi raised to 5 k raised to 4 t raised to 4 divided by h cube c cube. Therefore, you will get the expression for A also. A will be also proportional to 4th power of absolute temperature. But basically, we find A not for finding A. Actually, our aim is to find out entropy. If I want to find entropy, A is given by U minus Ts. Therefore, A is already given to you as minus 1 by 3 U, and U is there, U minus Ts. Therefore, Ts is equal to, if you add them together, Ts will be equal to 4 by 3 U. Therefore, what you have is A, the Helmholtz free energy from thermodynamics, U minus Ts. Therefore, A is minus 1 by 3 U, which is U minus Ts. I can take Ts to the left hand side and U plus 1 by 3 U, which is 4 by 3 U. So, what is your entropy? Entropy is 4 by 3 U divided by T. And what is U by V? U by V is equal to 3 by 15. 8 by 15, sorry, 8 by 15, pi raised to 5, k raised to 4, k raised to 4, t raised to 4 divided by h cube c cube, 8 by 15, sorry. Therefore, U will be equal to 8 by 15 into V, pi raised to 5, k raised to 4, t raised to 4 divided by h cube c cube. Therefore, S is 4 by 3 into 8 by 15 V pi raised to 5 k raised to 4 t raised to 4 divided by h cube c cube, and there is 1 t in the denominator, t. Therefore, all these are constants. These are constants. 1 t and this t raised to 4 becomes V t cube. Or what we can say is that entropy is proportional to V t cube. Or entropy, we will be able to get an expression like that, get an expression like this, that is 32 divided by 45. 32 divided by 45 will be there, V is there, you have pi raised to 5, k raised to 4, t cube divided by h cube, c cube. That is the actual expression for entropy. But we can say that entropy is proportional to V t cube. Why we require such an expression? This is a very important expression in the case of our black body radiations. We got entropy proportional to V t cube. We can have a large number of processes where the entropy will be remaining constant, and a process where entropy remains constant is called as an adiabatic process. Adiabatic process. Adiabatic process. During an adiabatic process, entropy remains constant, or V t cube will be equal to a constant. V t cube will be equal to a constant. We have a very important situation where the entropy remains constant. Very, very interesting property. The universe that we live in, or the world that we live in, is considered to be generated after a big bang. Earlier, our universe was at a single point, and we believe that, or there are a large number of experimental observations, data are available to say that the universe started after a big bang. A large number of data are available to show that this universe created after a big bang. Our study of black body radiation support this, because this universe that we live in is a closed universe. Nothing from this universe can escape from this universe. It is a closed one. Whatever things has been created after the big bang, whatever things that has been created after the big bang, we believe that the universe started from a single point, and there was a sudden burst was there, and all things after this burst started moving apart. And whatever things were at the beginning of the universe are still inside this universe. Nothing escaped from this universe. So what are the things that are available in this universe? After the Big Bang, what were the things that were produced? Radiations were produced. Photons are there. Radiation means photons are there. And some matter is there. Therefore, in our universe, in the universe that we live in, the Earth, the Sun, the solar system, the galaxies, all these things, we can say they are matter, and the remaining thing we can say it is. Therefore, it is radiation. Therefore, our whole universe, which is a closed one, what is after this, beyond this closed universe, we do not know. We live in this universe, and we are somewhere living here. And what this universe contains, it contains the photons which were generated at the time of Big Bang, at the time of Big Bang. And some matter is there, some galaxies and other things are there. Therefore, the whole universe is filled with the photons which were generated at the time of Big Bang. Therefore, these photons are subjected to expansion. What type of expansion? There is no exchange of anything between the universe and the outside world. Therefore, this is a closed universe, and this closed universe, you can say that this closed universe, when it is expanding, it is subject to an adiabatic expansion. It is subjected to an adiabatic expansion means this entropy remains constant. Entropy S, or there is a change in entropy, is equal to 0. Entropy, we found that for any adiabatic process for the photons, it is proportional to V T cube. Therefore, V T cube for the photons is equal to a constant. The photons inside this universe is subjected to an equation given by V T cube is equal to a constant. Therefore, the photons inside this universe, which was created after the Big Bang, is having the equation V T cube is equal to a constant. If you say that, if you consider that our whole universe is in the form of a sphere, you can rewrite your expression for the volume as 4 by 3 pi r cube, where r is the radius, T cube is equal to a constant. Is equal to a constant. Therefore, r cube T cube is equal to another constant. R cube T cube is equal to another constant. If I take whole raised to 1 by 3, whole raised to 1 by 3 on both sides, then you can say that RT is equal to a constant. RT is equal to a constant. This is the equation that governs our universe. Or for our universe, which contains photons, the majority constant of our universe is photons, they had been subjected to an adiabatic expansion. And the equation for that expansion is given by RT equal to a constant, which I can say R1 T1 is equal to R2 T2. if R1 is the radius of the universe at the beginning time, and if T1 is the temperature of the universe at the beginning time, R2 is the present radius and the present temperature. Therefore, the radius of the universe will be very small. If I say R1 is about 1 meter, the temperature will be very, very large, very, very large. Therefore, it is of the order of, even the temperature of the sun is 10 raised to 7. Therefore, let us take it is 10 raised to 10 Kelvin, 10 raised to 10. Therefore, 1 into 10 raised to 10. The present radius, you can say approximately some radius, you can say some approximate radius, I say 10 raised to 24, something like that. And then I can find out that temperature. If I say that temperature is there, just I had put this this radius is a very large quantity. I can have any radius. I can have the radius. I know what is the radius of the present universe, and then what you can say is that if this value is there, this R1 T1 is equal to R2 T2, R2 T2. Therefore, if T1 is very large, T1 is very large. To get this value, the temperature of the photons must, this is a constant, Therefore, the temperature of the photons must be very low to make it a constant. Temperature at the beginning of the universe, if it must not be 10 raised to 10, I just took an approximate value. For example, if the temperature at the beginning of the universe is 10 raised to 24 and the present radius is nearly 10 raised to 24, and the radius at the beginning of the universe, if it is 1, then I will get the temperature of the photons is about 1 Kelvin, or the temperature of the protons which are present now in the universe must be drastically reduced. At the beginning the temperature was very high. Now the temperature must be reduced to a very small value. People started exploring the whole universe by using different types of detectors. They scanned all over the universe. They found that the whole universe is filled with a kind of microwave radiations, and these microwave radiations have a temperature nearly equal to 2.7 Kelvin. And those radiations, we call it as cosmic background, CBR, we call it as cosmic background radiations, and the temperature of those radiations, it is found to be equal to 2.7 Kelvin. Or this basic thermodynamics of black body radiations gives you a beautiful idea that the whole universe started after a Big Bang. Since the photons, definitely at the time of Big Bang, the temperature of the photons must be very high. What we had seen is that the temperature of photons is very low. This shows that the temperature has reduced drastically to a very small value, which supports the Big Bang theory. This is the equation, T1 R1 is equal to T2 R2, and therefore, the temperature of our universe at present T2 is less than its value at the time of its origin T1. Then from the above equation, R2 must be greater than R1. This shows that the universe is expanding. Therefore, the study of black body radiations, which is the best example for the study of a quantum system, gives rise to a lot of ideas. One of the most beautiful idea is that the whole universe started after a Big Bang can be supported by studying black body radiations. Now, we can have some questions. For an energy state E of a photon gas, the density of states is proportional to what is the density of states? You can by what you can do is you can have this G of P dP is equal to 4 pi p square dP into capital V by h cube, and from taking that PC is equal to E or P is equal to E divided by C, you will be able to show that your density of states will be proportional to root E, and that which I can show you, that is the number of density of states is given by G of p dp is 4 pi p square dp into capital V by h cube. Here E is equal to Pc. Therefore, P is equal to E divided by C, or dP is equal to dE divided by C. I want only the proportionality. Therefore, I will not be accounting that number of two states. Two states, actually the photons will be having longitudinal state and that is transverse states. That I will not be taking into account. I will be taking only G of E, how much it is proportional to. Therefore, G of E will be proportional to, I will not take this 4 pi, I will not take this h cube. It is proportional to, this V also is a constant, it is proportional to p square dp, and the p square is E square by c square, and dp I can say it is equal to dE divided by c. It is dE divided by c. Therefore, you can say that your G of E is proportional to E square. The number of states for a photon is proportional to E square. Therefore, in this section what we had done is we had studied about the black body radiations, and this black body radiation study is very important in the case of quantum statistical mechanics. And in this black body radiations, we had found out the thermodynamics of black body radiations, like pressure. We derived the energy density. I showed you that pressure is equal to 1 by 3 times the energy density. Then we found the Helmholtz free energy A, which I got it as minus 1 by 3 u. Then that A is substituted in the equation A equal to u minus Ts, and I got the expression for entropy, which we found to be proportional to V T cube. And we developed a very important concept of the Big Bang theory, the idea of Big Bang theory, that is what will be the expression for the expansion of the universe by taking the photons to be undergoing in this universe. The photons will be undergoing an adiabatic expansion, and by taking that entropy to be a constant, we obtained the equation that governed the universe as RT is equal to a constant, where R is the radius of the universe and T is the temperature of the universe. Therefore, we can see that the temperature of the universe, which is actually the temperature of the photons, the majority content is photons, the temperature of the photons in this universe. We found that by using this symbol equation RT equal to a constant, we found that the temperature of the photons that is completely filled in this universe is about 2.73 Kelvin or 2.7 Kelvin. And those radiations we call it as cosmic background radiations. Thus, the study of quantum systems gives new insights into the study of physics. I hope you understood this section very well. We will be studying about other quantum systems in our next sections. Thank you.